Good day again. It's a great day for mathematics as always, and we are off and running because today, oopsie, we are going to talk about the discriminant of a quadratic, which has absolutely everything to do with the quadratic formula, which is shown here, and which always makes me think of a soldier. Why, you ask? Well, let me show you. Pow! Okay, that's 2A, yeah. Go away. I like the dude in the glasses. Oh, they are bad to the bone, aren't they? Okay, enough of the nonsense. I'm sorry, but here we go. So, you might know what the discriminant is, but you really need to understand the concept of it. So, I am going to solve these. I got the quadratic in the house right here just for reference. I know we could solve this one by factoring, but we are going to solve it using the quadratic formula. So let me get my handy dandy pen, my pen, here we go, and I want to go blue. Let's go a little thicker like that. Okay, so that would be, and I'm just using the quadratic formula which you're familiar with, so that's going to be x equals negative b, so that would be negative 4 plus or minus the square root of b squared, which is going to be 16, minus 4 times a, which is 1, times negative 5, which is c. Alrighty, all over 2a, which is 2. Simplifying that, we're going to skip steps in the interest of time. We get 4 plus or minus root 36. 16 plus 20 is 36 over 2, which gives us x equals negative 4 plus or minus 6 over 2, which gives us two different solutions, doesn't it? X equals negative 4 plus 6 is 2, divided by 2 would be 1, or x equals negative 4 minus 6 would be negative 10, divided by 2 would be negative 5. So we got two solutions there. Okay, and let's take a quick look at the graph of that. That's going to be here. And just like you learned before, it's a parabola, of course, and it intersects the x-axis at the solutions, x equal to 1 and x equal to negative 5. So let's go back, and we're just to be safe here, we are going to, I think I want to go back thin. Oopsie, nope. All right, right here. Okay, so we'll just sketch a quick little graph of that right here. And it was a parabola at negative 5, about like that, and 1, so intercepts the x-axis at negative 1 and 5. Okay, then we go over here and do the same thing. We're going to solve using the quadratic formula. X is going to equal negative b, so that's negative 4 plus or minus a square root of b squared, 16, minus 4 times a, which is 1, so I'm not going to put it, times negative 8, all over 2. So that's going to be x equals negative 4 plus or minus the square root of, let's see, 16 again. In the interest of time, 16, negative 4 times negative 8 is 32, so what's 16 plus 32? 40, that's going to be 48 over 2. And I know we could simplify that. I think 16 times 3 would be, well, let's go ahead and simplify it. So that would be x equals negative 4 plus or minus 4 root 3 over 2. And you can simplify this, remember, to be both of these are divisible by 2, obviously, so that would turn into negative 2 plus or minus 2 root 3. And remember, you have two solutions here, actually. Negative 2 plus 2 root 3 and negative 2 minus 3, x equals negative 2 minus 2 root 3. Okay, so let's take a quick look at the graph of that. And it's a similar parabola, but notice it does not intersect the x-axis at a whole number. It's right here, it's between 1 and 2, and then over here it's between negative 5 and 6. So we'll do a quick sketch. That makes sense. Negative 2 plus 2 root 3 would be over to the right, a little to the right of 1, and this one's going to be a little to the left of negative 5. So a quick sketch there, and we are going to have something like this. Two solutions, intersects the x-axis to the left of negative 5. Sorry about the scale there. To the right of 1. But I just want you to see two solutions, two intersections of the graph. Okay, then we go over here and we would solve using the quadratic, negative 4 plus or minus square root of b squared, so that's going to be 16. Minus 4ac is going to be 16. I'm moving this along over 2. So x equals negative 4 plus or minus. Hold the phone, Chuck. 16 minus 16 is 0. I have nothing to subtract, so that becomes negative 4 over 2, and x equals negative 2. Now I also want to do something here. This is the only one I'm going to do this for. I'm also going to factor this because that comes into play in just a second, and it becomes x plus 2 times x plus 2 equal to 0, and you can see how we get x equals negative 2. So we have one solution, but it's a little fishy. We'll get back to that in a second because it factors into two things. Okay, and so we'll look at that graph, and ooh, looky, it touches the x-axis right at negative 2. Interesting. So we're going to go back here and sketch that, and it looks like something like that. Okay, and that was at negative 2. And just pretend, humor me, that it touches the x-axis there. I'll make it a little thicker. There you go. Okay, and then finally we'll do this one. So x would equal negative 2 plus or minus square root of b squared is going to be 4 minus 4 times 3 all over 2. So x would equal negative 2 plus or minus, let's see, 4 minus 12. That's going to be the square root of negative 8 over 2. And hopefully you're like, hold the phone, Baxter. We cannot take the square root of a negative number. We can't find it just yet. Surprise later. So since there is no number when squared that gives us negative 8, no real number anyway, we would say that there is no solution to this particular quadratic equation. So sad. Aww. No solution for you. No soup for you. Okay. And real quick, take a quick look at the graph. Go to the right. And here it is. And lo and behold, the graph of this function does not intersect the x-axis, which is what we should expect exactly since there are no solutions. And any solutions would also show up as intersecting or touching the x-axis. So let's do a quick sketch of that. And what? Something like this. Oh, lonely parabola here not touching the x-axis. So there we go. Okay, so now what does all this mean? Well, here we had two solutions, but I want to take a real good look at the square root. Okay, so Here, let's go green. Pro environment, we'll go green. And if you look under here, once we simplified everything, we had a positive square root, which means we could take the square root of it, or it's an actual number. In this case, it was perfect square. We had -4 plus or minus 6, and so we got our two solutions. So with a positive number under the square root, we got two solutions, which makes sense because I had two things to subtract, and there they are right there, -5 and 1. Very similar here, positive under the square root, and we ended up with two solutions. Now they weren't as nice as these big thick ones over here, but they are two solutions nonetheless. They're just not whole numbers or integers, I should say. They're not integers. So we still had two solutions, which makes sense because even though it wasn't a perfect square, it was still positive under the square root. Now what happened over here? Well, we had 16 minus 16, which is, I'm going to go ahead and put a square root of 0 here. We had 0 under the square root, which means I had nothing to add and subtract, and I got one solution. I got one solution. And we're going to revisit that in just a second. Okay. And then here, looky, since I could not take the square root of a negative number, I got no solution. Or I guess I could say no solutions to this quadratic equation. And that makes sense because since I can't take the square root of a negative number, there's nothing, I can't add or subtract. It's right now it's nonsensical. It's not a number. It has no meaning to us. So what's going on here? Well, what's driving this is what's under the square root. A positive 36, a positive 48 gave us two solutions in both cases. A 0 gave us one solution, and a negative number gave us no solutions. Well, that's all because it's under the square root. Well, what's under the square root in the quadratic formula? Let's go orange, and let's circle. Well, let's move this guy over and let's take a closer look at him. Move him, he's a little more visible, maybe down here. Okay, and so if you look under here, you see b squared minus 4ac. Boys and girls, that is the discriminant. Oh, I got to do a hyphen. Anant. Nice. Okay. The discriminant, because the discriminant tells us a lot about the nature of the solutions of the graph. If I simply took b squared minus 4ac here, I get 36. And since that b squared minus 4ac is within or under the square root, if b squared minus 4ac is positive, I'm going to have two solutions, like I had here and here. If b squared equals minus 4ac equals 0, I'm going to have one solution. And if it's less than 0, I'm going to have -8. Or I'm sorry, if it's less than 0, it's not always going to be -8. I will have no solutions. No solutions. The symbol for the discriminant is the Greek letter delta. And we say that delta equals b squared minus 4ac. Okay, and we're going to use that a lot in just a second. Now, something that's very interesting is, since this is a perfect square, I have two solutions, and they are rational. So I have two rational solutions, and you might remember that a rational number is any number that can be written as a fraction. Okay. Here I have two solutions, and they are irrational because the square root of a number, I can't, if it's not a perfect square, I can't write it as a fraction. So I have two irrational solutions. They are also unique solutions because they are different. Okay, they are unique. And over here I have one solution, but we call this solution we call the roots a double root, and the reason we call it a double root is the solution actually appears twice, and you can see it better here with the factoring. I get -2 twice, but we're not going to say x equals -2 or x equals -2, so we just call that one solution with a double root, and sometimes we call it a repeated root. Different folks, different books do different things. Okay, and then no solutions, obviously there's nothing there, can't take the square root of a negative number. Okay, so this is all messy, and the next page we have a nice little chart here, and well, first we have this this sentence here. In the quadratic formula, the quantity b squared minus 4ac under the square root is called the, and let's go back to blue, is called the discriminant. There she blows. The symbol delta is used to represent the discriminant, so we say that delta equals b squared minus 4ac. It's just better to have that symbol instead of writing discriminant all the time. And here's what we found out. If delta equals 0, we're left with x equals -b over 2a. It's the only solution, and it's a repeated or a double root. That's because I don't have anything but 0 to add or subtract. And it's a repeated or double root because these are always going to factor into perfect square trinomials. If delta is greater than 0, the square root of delta is a positive number, so we have two distinct. I wrote unique on the previous page. That's just from a past life from me. I don't want to get into it, it's a little embarrassing. But distinct means different. I have plus the positive square root and minus the positive square root. That gives me 2. And if delta is less than 0, then the square root of delta is not a real number, and so there are no real roots. And this last thing we'll talk about in just a second. So, what can we do? Oops, got the dot. Oh well, we're going to have to build a bridge and get over that. Let me get rid of that rectangle, and we are going to use the discriminant to determine the nature of the roots of these two quadratic equations. So, here we go. So, delta equals b squared minus 4ac. So for letter A, that would be b squared -2 squared is 4 minus 4 times 2 times 3, and that is going to equal 4 minus 8 times 3 is 24, and that is -20. Now I really don't even care about the 20. What I care about is that the solutions are negative, or the solution is negative, or the discriminant is negative, I should say, and that immediately tells me there are no real roots because we can't take the square root of a negative number. And remember, this is what would end up under the square root because it's the discriminant, it's b squared minus 4ac. So b, let's see, delta would equal, what do we got here? B is -4, so that would be 16 minus 4 times 3 times -2. So that would be equal to 16, let's see, 12 to 24 and two negatives, so that's plus 24. So that's equal to 40. Okay, and that's positive, it's under the square root. So we are going to get two distinct, okay, it's not a perfect square, so those roots are going to be irrational. The square root of 40 is irrational. I cannot write it as a fraction, so I have two distinct irrational roots, two different irrational roots. Again, because I'm going to be able to, remember, that's going to be plus or minus the square root of 40, and I'll have blah, here negative b over 2a, blah, I don't want to go through that. I just want you to see plus root 40 minus root 40. That gives me the two distinct solutions. It's irrational because 40 is not a perfect square, and those are the roots. Okay, next example. Consider this, x squared minus 2x plus m equals 0. Find the discriminant and hence find the values of m for which the equation has a repeated root. Okay, so we're going to say b squared equals, delta equals b squared minus 4ac. So delta would equal, let's see, my b is negative 2, so that's negative 2 squared is 4, minus 4, a is 1, so I'm not going to put it there, and c is m, so 4 minus 4m. Okay. So for a, I needed a repeated root. Well, a repeated root happens when delta equals 0. So I'm going to say 0 equals 4 minus 4m. And if I solve, negative 4 equals negative 4m, and m equals 1. So in order for me to get a repeated root, I need just one solution, which again, it would factor into a repeated or double root. And for that to happen, I need m equal to 1 for this particular equation, because that would create a discriminant of 0, and I wouldn't be able to add or subtract anything, and I would get one solution. But again, that is a repeated root. B, two distinct real roots. Well, that means I need delta greater than 0. Okay, so that means I'm going to rewrite it this time. I should have done this in the first place. 4 minus 4m must be greater than 0. So solving, I would say negative 4m is greater than negative 4, and m is less than negative 1. So that means for any number less than negative 1, I will get two distinct real roots, because that will make my discriminant, there's my discriminant will be greater than 0. It will be positive. Okay? And then for there to be no real roots, I would have to say 4 minus 4m has to be less than 0. Solving, I get, again, it's really the same thing here, isn't it? It's just I started off with a different inequality, so we can quickly do this and divide by negative 4, which switches the inequality, so m must be greater than 1, oopsie, and must be greater than 1. Look what I did here. I hope that was bothering you. I need to erase that. Re-explain it. A negative 4 divided by negative 4 is a positive 1, so m must be less than 1 to get two distinct roots, because I would have something positive under the square root. Here m must be greater than 1, because I would have something negative under the square root, which would give me no real roots, no solutions, and equal to 1 to have 0 under the square root, the discriminant equal to 0, which would give me a repeated root, one solution and a repeated root. So sorry about this little mess up here, and that's all we got for the discriminant. See you soon.